When it's coming apart, you had it all. It wasn't enough. No, it's not enough.
Cars drive great on roads, but not so great when the roads become covered with snow or mud. Snow and mud reduce the amount of traction your car's tires have. Traction, or tractive force, is the force used to generate motion between a body and a tangential surface, through the use of dry friction, though the use of shear force of the surface is also commonly used. Reduce the traction far enough and you won't move anywhere. If your car gets bogged down in snow or mud, it doesn't do any good to accelerate in an effort to move. Traction doesn't depend on the speed of the tires. In fact, traction can be reduced by rapidly spinning wheels, which tend to slide even easier on the snow or mud. You can try a few things. First, move the tires ever so slowly. The slow movement won't cause the tire to slip and should provide the traction you need to move. Second, remember that the car isn't moving because it doesn't have any traction. Try to dig out a bit of the snow or mud from in front of the power wheels, the ones that actually turn when you step on the gas. Then, wedge a car mat, blanket, or old coat under the leading edge of the wheel. Inch the car forward until the tires grip on the item, and then slowly drive the car out of the snow or mud. Remember that the concepts of friction and traction are essential to driving.
They tell you it's not worth the price, so just let it go.
We've all been there, drivers or passengers. We've experienced sudden heavy braking. We're moving at a certain speed when the driver rushes, hitting the brakes, and we continue to move forward even though the vehicle is already slowing down. Some suggest that these sudden stops cause quite the shock and are harmful to the body. Studies show that they are, but this shock doesn't really do much harm. Sudden braking would be a big problem if you're in a bus and you're standing and the stop caused you to fall. There's nothing we can really do about it but get a good grip on handrails. Organizations are suggesting that the government should fund programs that give awareness to drivers on proper braking. They say that there are many types but drivers only use the one which stops the vehicle the fastest. There are ABS systems, threshold braking, and more types, each with their own strengths. So passengers, simply take care, and drivers, be more careful.
But you know you can. You know you won't.
To help protect you in auto accidents, your car can be equipped with front and sometimes rear crumple zones that are designed to absorb the energy of impacts or crashes in a predictable way. Generally, prior to the 1960s, people assumed that the stronger the backbone structure of an auto, the safer the car. The truth is larger than this. By Newton's third law, for every action there is always an equal and opposite reaction. If an object in motion, such as a car and the human beings inside it, is going 50 miles per hour and hits a wall, the bodies inside will be acted on by the wall with equal and opposite force. As the crash continues, so does the force on the wall and the wall's vibrating force on the bodies. For example, if a solid train hits a wall, you may think that it only collides once. But recent accelerometer measurements indicate that the wall pushes back nearly 10 times during the collision, even though the wall is not literally moving. This crash pulse can shake a human body around and really cause some damage. Human beings need something to absorb, not transmit, that energy before it reaches us. Plastics play a life-saving role. Recent research shows that designing automobile front ends with crushable composite structures can help dissipate Newton's reverberating energy. Carbon-reinforced plastic composites can absorb 6 to 12 times the energy of steel, yet possess required strength and stiffness at less weight. These structures absorb energy as they crush. So, engineers try to create a crush zone of these composites to absorb and dissipate violent energy. Today, lightweight plastic composite crumple zones can allow the front of the vehicle to crush predictably like a semi-solid foam-filled accordion, absorbing much of the impact and giving off energy in the form of bending plastic or brooming fibers, as opposed to 100% pure bone-crunching kinetic energy, thereby helping to reduce slamming forces upon impacts and help save lives. At the same time, its lighter weight saves gas and therefore greenhouse gas pollution for the car's entire life.
It's not easy, no, finding.
Okay, imagine being one of the children on this bus as it swerves across the road and then flips over.
Extremely unnerving, and it seems like this that have some questioning whether rules about seatbelts on school buses need to be tightened. And I recently got a first-hand look at some of those frightening crash tests.
Watch the terrifying moment this school bus topples over the edge of the road, released on Thursday. You can hear the children on board screaming. And Friday, another frightening scene near Birmingham. This school bus slamming into a tree, injuring 16 with 2 children and an adult airlifted to nearby hospitals. These horrific crash scenes showing the potential devastation bus riders face, made worse when there are no seatbelts on board. In the U.S., only 6 states require all school buses to be equipped with seatbelts. In the other 44, they're only mandatory for small buses under 10,000 pounds. To learn what happens inside these crashes, GMA went to the scene of crash tests run by IMI, one of the nation's leading seatbelt providers in the school bus industry. The first test capturing what happens when a school bus collides with the wall at 30 miles an hour.
Oh my gosh, that was terrifying.
And next, IMI creates a rollover crash like the real-life scene in Tulsa on Wednesday.
You can see that the 2 children that are belted, they're in their compartments and they're safe. The children that are unrestrained, they're thrown throughout the vehicle and they hit hard surfaces.
The National Highway Traffic Safety Administration, which regulates schools' transportation vehicles, told ABC News in January they are now looking at the issue, but still haven't required a mandate for seatbelts on school buses, saying they're
With summer just around the corner, group travels are common, and one of the public transportation vehicles you might take is the bus. However, you must pick the safest seat in order to avoid further complications when an accident might happen. Seating in the front row is vulnerable to head-end collision, while in the back row makes it to the highest risk for rear-end collision. With this being said, the most safest spot in the bus is the middle row.
Words to say when you're feeling lost.
Why is standing near the edge of the platform of a train station dangerous? According to Daniel Bernoulli, an increase in the speed of the fluid occurs simultaneously with a decrease in its pressure. This was stated in Bernoulli's principle. When you stand close to a train which has high speed, the air that moves with the train has to pass through a channel shaped by your body and train, so, the speed of air has to increase to pass this narrow channel, and thus, the pressure of air between you and train falls dramatically. In this case, the air behind your back has more pressure on your body, and you feel that an invisible hand, that is the air pressure force, is pushing you towards the train. This can become as big as 190 kg. It means if you stand really close to a high-speed train, the air pressure force will be high enough to push you under the wheels, so be careful and heed the instructions of the guards.
You'll find your way.